Okay. Hi, Doc. Good night. And I am Johan Silva of the career of bioclimatical architecture. And today I'm going to present my video about the integration methods. Well, my index is I wanted to present 4 different methods of the integrations. The first is the integration by fraction partial. The second one is the integration by parts. The third one is the integration by variable change method. And the last is the integration by trigonometric substitution. Well, by the first, that is the integration by fraction partial. Well, let us to consider the integral, that is this one. Well, we have the derivative in parentheses 5x plus 3 divided for x potential 2 plus 2x minus 3. We close the parentheses and dx. Okay. Well, the rational function is 5x plus 3 divided x potential 2 plus 2x minus 3. Well, we can decompose it into the sum partial fractions. For this sorry, for this we need to know the real roots of the denominator, denominator, sorry, such as x potential 2 plus 2x minus 3, that is this number, or this part, that is equal to in between parentheses x plus 3 x minus 1, that is the same of this. So we're gonna change this part of down, and we're gonna interpret this part, this form, 5 and this 5x plus 3 and divided to x potential 2 plus 2x minus 3 is equal 5x plus 3, sorry, divided between parentheses x plus 3 x minus 1. So in this part, sorry, now in this part, then by the method of partial functions, there are constant 8 and b. We have in this part 8 and b. Well, we're gonna change this part. We're gonna aggregate some another division. So we have this operation that is equal to a divided x plus 3, that is in this part, plus b divided x minus 1, that is in this part. Well, to determine the constant, we can use one of the node methods. For example, multiplying both sides of the expression by the denominator. Well, that is in this part. 5x plus 3 is equal to a in between parentheses x minus 1, we close the parentheses, plus b open the parentheses x plus 3 and open and close the parentheses. Now we're gonna evaluating the equality at x, that is equal to 1, and so we obtain 8 that is the result of this part, that is equal to 8 per 0, that is the in this part, x, that is equal to 1. 1 minus 1 is 0, plus 8b, so b is equal to 2. Now, evaluating the equality that x that is equal minus 3, we obtain and this part minus 15. Remember that the x is equal to 3, so and we're gonna to multiply this part. 5 por 3, 15, plus 3, that is equal to 8. Open the parentheses, minus 4, close the parentheses, plus b per 0, so 8 is equal to 3. Well, we're gonna to continue with, we're gonna change the values of a and b for the values in this part, b and a. So we have the in this part, okay, in this part, 5x plus 3 divided x potential 2 plus 2x minus 3 is equal 3 divided x plus 3 plus 2 divided x minus 1. So we're gonna do the solution in this part, and the derivative between parentheses 5, that, well, is the same in this part, is the same value in this part, sorry. So we have the is equal to the derivative between parentheses 3 and this the same values of this part, and close the parentheses, and the x, all this is equal to 3 the derivative dx divided x plus 3 plus 2 the derivative dx divided x minus 1. So we obtain 3 natural logarithm. I don't know how do you say logarithm or natural in English, but I wanna say natural logarithm of x plus 3 plus 2 natural logarithm of x minus 1 plus c, and that's it. Okay, well, I'm gonna to continue with the second topic, that is the integration by parts. So in this part we have the integration one, well, the derivative, and that is the derivative x e and potential x dx. So we're gonna have to separate it and divide it. I don't know how do you say sectional and these elements. Well, in this part we have the u that is equal to x in this part, x, du that is equal to dx in this part, and db that is e potential x and dx in this part, and finally b that is equal the derivative x, no, the derivative e potential x dx that is equal to e potential x. So we're gonna in this part we have the formula that is the derivative of u db that is equal ub minus the derivative b du. We have to change these values or these letters for the values of in this part. So we obtain the derivative in this part. The derivative x e x, bueno, e potential x, that is the in this value, dx, that is equal to x e potential x, that is in the value the value of u and b, that is x and e potential x, minus the derivative e potential x dx. So the second part, well, in this section, we obtain x e potential x minus e potential x plus c. We have to, or we can to factorize this part, and we obtain, and finally obtain the derivative x e potential x dx, that is equal to e potential x between parentheses x minus 1 plus c, and that's it. Okay, I am gonna continue with the third example and the third technique, and that is the variable change. And this is a technique that is used in calculus to simplify the integration of functions. It consists to replacing the original variable with a new variable that simplifies the function. Well, in this space, this is the example, that is the derivative of between parentheses 2x plus 1 and close the parentheses, and with potential 5 dx. Well, by answer this integral, we can make a variable change, let u, that is u is equal to 2x plus 1. So du divided of about dx is equal to 2. Well, we can rewrite the integral in terms of u. We obtain the derivative between parentheses u in potential 5 and between parentheses 1 about divided 2 and close the parentheses du. Simplifying this integral, we obtain this must be peaceful. We obtain between parentheses 1 divided 2 and close the parentheses, and the derivative u potential 5 du. Now we can integrate with respect to u. So we obtain the between parentheses 1 divided 2 and close the parentheses parentheses u potential 6 divided 6 or about 6 and close the parentheses plus c, and this is the answer, and that's it for this technique, that is the variable change.